complicated two-step equations. So far, most of the two-step equations we've looked at look something like this. A number times x plus or minus another number equals some other number, right? And we solve these first by adding or subtracting. So in this case we get 3x equals 15, and then by either dividing or sometimes multiplying. In this case we divide by 3, and we get x equals 5. So we add or subtract, then we divide or multiply. We get rid of this number, then we get x all alone. Okay. We're still going to be trying to get x all alone today. That's still our goal. But there are other ways that we could have a two-step equation that wouldn't necessarily follow the same exact pattern or algorithm. And so what I want to talk about today is how do you just look at a problem and figure out how to get x alone. So here's an example. Let's say I have something like this. X plus 3 over 7 equals 2. X plus 3 all over 7 equals 2. Now if you followed the algorithm, or if you tried to follow the algorithm that we did before, you would try to subtract 3 first, but it's not really 3, it's like 3 over 7, and then you would have like minus 3 over 7 over here. You could do it, but it's not the ideal way to solve this. Because in this case, there's a much easier first step. What could we do in this type of equation just to get rid of this 7? Yeah?
You divide 7? I mean, multiply 7?
Multiply by 7. Watch what happens if I multiply this whole side by 7. I have 7 times something divided by 7. Imagine this thing is like 1. So I would have 7 times 1 divided by 7. That would just be 1. Imagine this were 7. No, let's not do 7. Imagine this whole thing were 4, right? Imagine this whole thing were 4. 7 times 4 divided by 7. So that's going to be 7 times 4 is 28. Divided by 7 is 4. If I multiply 7 times something and then divide it by 7, the 7's just cancel out. And then I also have to multiply 7 over here. Now, another way of thinking about this is I'm multiplying times 7 over 1, which is the same thing as 7. And I just look at my upstairs, downstairs canceling. Okay? Upstairs I have a 7. Downstairs I have a 7. So over on this side I just have x plus 3 left. Over on the other side I have 2 times 7, which is 14. Now what do? I want to get x all alone. What's my second step here? Yeah.
Divide 14 by 3?
What does this say? X times 3?
Plus.
X plus 3. What's the opposite of plus?
Oh,
Subtract 3 from both sides.
Subtract 3 from both sides. Very good. X equals 14 minus 3 is 11. Now let's say you don't believe that. You're like, no way. X can't be 11. I would recommend that you go back to this original problem and you plug in x. I think x is 11. So I'm going to rewrite this problem, but instead of writing x, I'm going to write 11. Everything else I'm going to write the same. So now I have 11 plus 3, which is 14
divided by 7.
over 7. See, I told you it wasn't correct. This one's 14 over 7, and this one's 2. Yeah.
But wait. But 7 is half
14 divided by 7 is 2.
Because it's half of 14.
2 does equal 2. Yay! Check. It worked.
That makes sense.
So it actually works. X actually is 11. Because 11 plus 3 divided by 7 does equal 2. Let's do another one that's similar to this. Let's say I have something like x minus 5 over 10 equals negative 3. Alright, what am I going to do when I see this problem? I want to get x all alone. What would be the easiest way to start out in this problem? The easiest first step. Yeah.
You multiply by 10.
Multiply by 10. So I'm going to multiply this times 10. Multiply this side times 10. Over here, the 10s cancel, leaving me x minus 5. Over here I have negative 3 times 10. A negative times a positive is a negative. 3 times 10 is
Negative 13? Or negative 30? Yeah.
so x plus 5 equals negative 30. How do I get x alone? It's not quite there yet. Yeah.
Subtract 5 from both sides? Or 30?
Subtract 5 from both sides. Let's see, x minus 5 minus 5, x
add
minus
5.
10.
Add 5.
Oh yeah, that would be better, right?
Yes.
Adding
Sorry.
5 would probably work better.
I said that wrong, I'm sorry.
Yes, you did.
Let's add 5. That'll give us a better answer, I think. It'll get us to the answer faster. You totally could subtract 5 from both sides.
Just takes longer.
Yeah, it just gives us an extra step. So x equals negative 30 plus 5. Those are opposite in sign. Which one is bigger, the negative number or the positive number?
Positive.
Really?
Oh, negative.
The negative number is bigger. So my
Negative
answer is going to be
25.
negative 25. That's my answer. Let's just check this one too. So I think x is negative 25. So going back to my original problem, let's write this out to check. Negative 25 minus 5 over 10 is supposed to equal negative 3. What is negative 25 minus 5? That's the same thing as negative 25 plus negative 5? Yeah.
Negative 30?
Negative 30 over 10 equals negative 3. Negative 30 over 10 is negative 30 divided by 10, which is negative 3. Boom. It checks. I guess we don't, when you check your answer, you don't really circle that result, but it does check out. That actually did work. So my answer, x equals negative 25. Yeah.
I'm pretty sure I have a system that can be used with students that could probably make it sound easier. Like with doing negatives and positives.
Okay, what is it?
Or with negatives. Like with negatives, you can think of it as if like a neighbor is borrowing your sugar and then which is borrowing the negative sign. And so you do the problem and you return the negative side to the final answer.
So for multiplying negative, is that kind of what you're
Yeah.
thinking of?
Yeah.
Cool.
I just thought of that.
So if you have one negative, you return it to your final answer.
Yeah.
When you're multiplying.
Yeah.
It's a cool way of thinking about it. Alright, what if we had something like this? 4 times x minus 14 equals 12. That looks a little weird, doesn't it? We have these parentheses.
Those mean to multiply, right?
Yeah, that means like multiply all of this times 4. How am I going to get x all alone here? Yeah.
Well, you can add 14 first.
could do that. I'm going to show you what would happen if we added 14 first. 4 times x minus 14 plus 14 equals 12 plus 14. Can I somehow get this inside of these parentheses?
No.
Not really, right? I'm adding it to this side of the equation. I can't add it just inside the parentheses. I have to add it to the whole thing. So this strategy, it will not be the best strategy for this particular equation. Remember what we said? 4 with the parentheses. This means 4 times all of this. How could I get rid of the parentheses? There's a couple ways. The easiest way would be if I just didn't have to multiply anything. So I have 4 times something. What's the opposite of times? Divided by. So what if I just divided by 4? On both sides. Now I can cancel upstairs, downstairs. We would have x minus 14. I don't need the parentheses anymore because there's nothing outside them. Right? X minus 14 is the same thing as x minus 14. Equals 12 divided by 4 is 3. Huh. Now what could I do? Now I have this minus 14. So now if I add 14 to both sides, I would just get x over on this left-hand side. And 3 plus 14 is 17. Let's kind of check this to see why it works. The reason it works is that in PEMDAS, we have to do the parentheses first. Right? So the first thing I do here is 17 minus 14. So I have 4 times 17 minus 14 is 3 equals 12. 4 times 3 is 12, which equals 12. So this checks. Okay, let's do another one like that. So you're writing every single step down in your notes, right? Each step, everything that I wrote on the board should be in your notes. And if you want to write a comment, because sometimes I say something, but I don't necessarily write it on the board, you can write that down in your notes as well. All right, so next thing for your notes. So we have 5 times x plus 11 equals 35. Okay, what's kind of in the way of the x on this left-hand side? There's a couple things, but there's one thing I have to deal with first in this case. And it's the thing that's outside of the parentheses. Yeah, it's that 5. This 5 is being multiplied times the parentheses. So to get rid of it, I'm going to divide both sides of this equation by 5. So now in your notes you should be writing divided by 5 on both sides of that equation. How come I don't subtract 11 first? Like if I had, yeah?
No.
If I had this equation, 5x plus 11 equals 35. Don't write this in your notes. But if I had this, I would subtract 11 first, right? What's the difference between this and this? What does this equation have that this one does not? Yeah.
You don't have to. Well, I'm going to take that as one.
They both have a 5, they both have an x, they both have an 11, they both have an equal sign, they both have a 35, they both have a plus symbol. Yeah.
They don't have parentheses.
This one doesn't have parentheses. Oh, right. when this is in parentheses, I have to wait to deal with it. You guys see that? Here, there are no parentheses, so I can just immediately get rid of that 11. This is not the problem we're doing. In the problem that we are doing, I have these parentheses surrounding my x plus 11. I have to first deal with everything that's outside of the parentheses. In this case, the 5. The opposite of 5 times something is divided by 5. So I divide both sides by 5, those 5s cancel. I now have x plus 11. I don't need the parentheses anymore because there's nothing outside of them on this side of the equation. Right? And then over here I have 35 divided by 5, which is
7.
7. Now I'm going to subtract 11 because I don't have it in parentheses anymore. X equals 7 minus 11 is negative 4. Okay? That's it. That's it. So the key to these types of problems is to deal with what's inside the parentheses second or last, right? You wait and deal with what's outside the parentheses first. Let's take a look. If I had something, let's do this. 3 plus x inside parentheses times 4 equals 32. What is outside my parentheses over here? 4. How do I get rid of that 4? Divide by 4. Very good. Boom. 3 plus x equals 32 divided by 4 is 8. You guys agree? Now what do I do? 3 plus x. What's in the way of that x? The 3. How do I get rid of the 3? Minus 3. So 3 plus x minus 3 is just x. 8 minus 3 is 5.